5th grade. Today we're going to be doing Module 3, Lesson 1, and since we are beginning the start of a new module, our lessons might look a little bit different because we're going to be starting with a lot of different little visual models like this one. And today we're going to be talking about making those equivalent fractions. So in front of you, you should have a couple of strips of paper that look something like this. And we're going to be talking about making equivalent fractions, and we're also going to be talking about making number lines today. And what we're going to be starting off with is we're going to be taking a look at our half fraction strip. So I know that all together, this is a whole strip of paper. But I split my paper so that I split it in half, and I now have two different halves that make up my whole. So when I think about the question, what fraction of the whole is 1 part? I know that half is a fraction that makes up 1 part because I have 1 half here and I have a second half here. When I add those two together, I get a whole for my fraction strip. Now that might sound a little bit confusing, but we're going to keep working with our fractions until we can make sense of this. So what I'm first going to do is I'm going to construct my number line. And the number line is going to help us get an idea of where our fractions are at on the number line. So I'm going to lay my fraction strip as close as I can to my number line. And then where I see I have this little line right here, this shows me what the halfway point is. Because from here to here, it takes me a half to get to that part. So this we're going to label as 1 half. So we have 1 in our numerator and 2 in our denominator. And that tells me, this first part tells me the parts. So I have 1 part out of 2 whole, or 2 pieces that will make up my whole. So this shows me it takes me 1 part, and there are going to be 2 parts needed to make up the whole. Now over here we will continue to fill in, and I'll think about, well, how many halves are needed to get to this point? Well, this is the start of my number line, so I'm actually going to have 0 halves. I don't need any parts to get to the start of my number line. That is just the start. Now for this part over here, this is where it might get a little bit tricky. To get all the way over here on my number line, I need to have 2 parts, or 2 of my halves to create my whole. So I need 2 parts to make my whole, and my whole is 2 pieces. So just to re-explain, the beginning of my number line usually is going to start with a 0. So I have 0 halves because it takes me 0 halves to get to this part. My midpoint, or the middle of my number line, it takes me 1 part, so 1 half, to get to this middle of my line. Now over here, it takes me 2 parts, or 2 halves, to get to my whole, which is my whole number strip. So please make sure you have copied this number line, and then we're going to take a look at making equivalent fractions. And how we're first going to do this is with these little visual models. So over here is just your simple half. So it's like I took maybe a cake pan, and what I did is I split it in half. So we split it in half like this. I shaded in this part, and maybe this is the part that Mrs. O'Mara eats. So I ate half of the cake pan. Now over here, this picture looks kind of similar to the picture we were just looking at. I still ate half, and now there's 2 different pieces. And I'm going to explain what we just did right here. So what I did is that when we create equivalent fractions, we are creating fractions that are going to look different. They're going to have different numbers, but they mean the exact same thing. So for this example right here, what I did is I took this half, and I took that half and I made it into groups of 2. So I took this part right here and I split it down the middle horizontally, and I made 2 new groups. And remember, when we talked about when we have multiplication, we can think of this multiplication symbol as groups of. So it's like I took this 1 group and I made it into groups of 2, just like I did right here. And now I have that number 2, because 1 times 2 is 2. Now I took the whole, my denominator is my whole, and what I did is I took these 2 groups that I had, 1, 2 groups, And I made them multiply as well because now I have 2 groups with 2 in each group. And 2 times 2 is 4. Now, this might be a little bit confusing right now, but a way of understanding it maybe a little bit easier is when I look at this half, I see that I have one part shaded in. There's just one box shaded in, and that is my numerator. So it's kind of like my numerator is how many boxes are shaded in. But this bottom number here tells me the total amount of boxes. So that doesn't matter if, this doesn't matter if they are shaded in or not, it's just how many total boxes I have. So I have 1, 2 boxes right here. And that's why I have a denominator 2. When I look at this 2/4, I can tell that this shaded part right here looks exactly like this shaded part, but my numbers are changed. And the reason why that is because I now have 2 shaded in sections. So that's my numerator, so I have 2 parts. And my denominator has changed to 4 because now I have 1, 2, 3, 4, and there needs to be 4 parts to make up a whole. So just one more time, I have 2 shaded in parts. The parts go on top, and then the whole, or the total, is the number that goes on the bottom. So we're going to try this again with our next set. And now instead of breaking it into groups of 2, I'm going to break this into groups of 3. So I'm going to start off by drawing a half right here. And most of your problems, you're going to start off by drawing this basic fraction, and then you split it up into smaller and smaller groups. So now I'm starting with a half. And what I'm going to do is I'm going to split them into groups of 3. So that's why I'm going to be multiplying times 3 right here for both my numerator and my denominator. And when you get to your problem set, make sure you copy down all this because this is going to help you out a lot to understand what you need to do. So I have 1/2 broken into groups of 3. So to break it into groups of 3, what I'm going to do is horizontally, so kind of sideways, I am going to cut this box into 3 parts. And I did that by cutting it into 1, 2, 3 parts just like that. And now why I'm doing this math right here is this math right here is showing me how many boxes are now shaded in and how many total boxes I have within this square that I have. So it's like I've changed the numbers, but I still technically have the same amount. So even if Mrs. O'Mara said I only ate half the cake, or I said I ate 2/4 of the cake, or I ate this much of the cake, it's still the same amount. So I do 1 times 3, which is 3, and then I do 2 times 3, which is 6. So 3, 6, 2/4, and a half all equal the same thing. It's just different ways of looking at it. So it's like now 3 people maybe could get a slice of cake, but it's still the same amount. Now, one more time over here, we're going to try this, except we're going to break it into groups of 4. So I start with my half, just like I did over here, except now I want to think about, well, if I have a half, what happens if I break it into groups of 4? And do you see I'm increasing the number here? We have groups of 2, groups of 3, and now we have groups of 4. So I'm going to horizontally, so sideways, break this into groups of 4. So now I have 1, 2, 3, 4 groups. And then when I do the math for this, I'm thinking, well, how many shaded in pieces do I have? Well, I have one group of 4, so I have 1, 2, 3, 4 shaded in parts. And then how many total boxes do I have now that make up my whole? Well, that would be 8, because I have 1, 2, 3, 4, 5, 6, 7, 8. And then I get 4/8, and 4/8 is the same thing as 3/6, 2/4, and a half. So when I take a look at a number line, what I can do is I could also label this as 4/8. I could label it as 3/6, or I could label it as 2/4, because all of these mean the same thing. And these will help you when you go to label number lines that have these fractions or that have these numbers in their denominator. And we'll talk about that in a little bit. So now let's move on to our next problem. And for this next problem, we are going to have our third fraction strip out. So now this third fraction strip, what this means is that now I have to have 3 parts that make up my whole. So I have 1, 2, 3 parts that make up my whole. So that's why I bended it in 3 different spots. And now I'm going to lay this down next to my lumber line, and I'm going to put a little mark wherever I see a third, wherever I see these little lines. And what this tells me is that from the starting point to here, it takes me 1/3 to get there. Now, it takes me another 1/3 to get to this point, but instead of labeling this as 1/3 again, I think about, well, how many thirds in total did it take me to get to this point? So I could think of what's 1/3 plus 1/3. So I have 1 plus 1, which is 2. So it took me 2/3 to get to that point. Now, when I think about the very end of my number line, I think about, well, how many thirds did it take me to get to the end of my number line? Well, I have 1/3, 2/3, 3/3 to get all the way to the end of my number line. So I'm going to label this as 3/3 down here. Now, at the front of my number line, I think about, well, how many thirds did it take me to get to that point? 0/3, because I didn't count by thirds just yet. That would be 0/3. So we have 0/3, 1/3, 2/3, and 3/3. And you can even see the pattern in that numerator. Took 0 parts, 1 part, 2 parts, 3 parts. And we're trying to get to that whole. So now we're going to do equivalent fractions again, but now we're going to be working with thirds. So what I'm first going to do is I'm going to take this first box and I'm going to split it into thirds. And when I split it into thirds, usually when I'm splitting a box to show a fraction, I always want to start with vertical lines. So that's those up and down lines. I always want to split it into vertical lines first. So that's what I did right here, up and down lines to show you what 1/3 looks like. Then after I show you what 1/3 looks like, I want to think about, well, what equivalent fractions could I create with 1/3? Well, I usually want to start with the number 2 because that's the easiest one for me to do. So I think about, well, if I have 1/3 times 2, or 1/3 groups of 2, what would that equal? What would that look like? So when I want to split this into groups of 2, what I'm going to do is I'm going to take these horizontal lines now, so these sideways lines, and I want to split it down the middle. And the reason why I split it down the middle is because I'm creating 2 groups now. So when I create those 2 groups, I'm doing 1 group of 2, or 1 times 2, which is 2, and then 3 times 2, which gives me 6. So now I have 2 parts filled in, and that's why my denominator is 2. And there are 1, 2, 3, 4, 5, 6 total parts. So 2, 6 would go right here. Also, 2, 6 is the same as 1/3. So if I had to label a number line with 6, or find where 2, 6 would go on a number line, that is where that would go. Now for my next box, I'm going to continue to draw that 1/3 first. So 1/3, remember, we always start by drawing it vertically to just show what the fraction looks like, and then we can divide it up to find our equivalent fractions. So for this one, since I already did 2 groups, I'm going to try and split this into groups of 3. So I will split it into groups of 3 by drawing lines horizontally. So I now have 1, 2, 3 groups. So, as you can see, I still have the same amount. The amount isn't changing. It looks exactly the same. The only thing that is different is the amount of groups that it's being split up into. So now I have 1 times 3, which is 3, and 3 times 3, which is 9. So this shows 3/9 because I have 3 parts shaded in out of 9 total parts for this square. Remember, 3/9, 2, 6, and 1/3 are all the same thing. Now for our next 2 boxes, we're going to continue splitting up our thirds. So now we have, again, 1/3, but this time we're going to be splitting 1/3 into groups of 4. So if I'm splitting it up into groups of 4, I now have to go across and create groups of 4. So I have 1, 2, 3, 4 groups now I'll multiply 1 times 4, which is 4, and 3 times 4, which is 12. And what this gives me now is I have 4 shaded in parts, 1, 2, 3, 4, out of 12 total parts. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4/12 is another equivalent fraction to 1/3. And finally, we have 1/3, and now I'm going to be splitting it into groups of 5. So I have 1, 2, 3, 4. And when I have 1/3, and I'm trying to figure out the groups of 5, I will get 5/15. And I can check my model to make sure I'm correct. I have 1, 2, 3, 4, 5 parts out of 15 total parts to make up a whole. So that is how we work on this part. And like I said, make sure you keep these notes because these notes are going to be super important for when you do your problem set, your homework set, and your exit tickets. So let's flip this page over, and now we're going to be looking at something that's going to be a little bit more challenging, a little bit more difficult. Because what I have right now is 2/3. So it's been pretty easy so far to do like 1/3, 1/4, because our numerator has always been 1. But what do I do when I have a different number in my numerator? So again, we have our little number line here. So we have 0/3, 1/3, 2/3, and then 3/3, or we can say that equals 1 because 3/3 equals 1 whole. But right now I'm trying to find an equivalent fraction for 2/3. So that's why I have this little or part here, because I'm trying to figure out what 2/3 could also equal. So what I have over here is this is a model to show 2/3. I took a square and I split it into thirds. So I have 1, 2, 3 parts, but only 2 of them, or 2 parts, are filled in. So 2 of the 3 parts are filled in. And what I want to do is I want to think about, well, what are some other equivalent fractions I could make? So I could really pick any number that I can multiply it by right here and find an equivalent fraction. But I'm just going to do 2 because I think that will be the easiest for me to do right now. So as long as the top and bottom number are exactly the same, then you could split it up and find an equivalent fraction. So what I'm going to do is I'm going to break apart my model right here to show that I am now creating 2 groups. So I started with thirds, and now I'm breaking it into 2 groups, so 1, 2, and then I will multiply. So I have 2 times 2, which is 4, and 3 times 2, which is 6, which gives me 4, 6. And I can check my answer by looking at my visual model, because I have 1, 2, 3, 4 shaded in pieces out of how many total pieces? There are 6 total pieces, because I have 1, 2, 3, 4, 5, 6 total pieces. So 2/3, or 4, 6, equal the same thing. Now we're going to try our biggest and most difficult problem for today, and we're actually not going to have a you try problem, so just follow along with me on this last one. And when we take a look at this fraction, what you're going to notice is that I have 5/4, and normally my numerator is not going to be bigger than my denominator, but in this case it's actually going to be bigger because I have 0/4, 1/4, 2/4, 3/4, 4/4, or 1, and then I have 5/4. So this fraction is actually greater than 1. And since this fraction is greater than 1, what I'm going to need to do to show 5/4 is I need to have 2 different squares, because this right here is 4/4. So remember, 4/4 equals 1. So 4/4 is going to make up a whole, and then I still need a little bit more. So that is why I have this extra one over here, because now I'm showing you 1/4, 2/4, 3/4, 4/4, and 5/4. And that is why I split this model into fourths as well, so you can see that extra fourth. Now, when I want to find an equivalent fraction for this one, it is just like all the other problems that we have done. The only difference is that I now have 2 different models to work with. So I'm just going to try our usual, let's split them into groups of 2. So I'm going to split this model into groups of 2. So I have 1, 2. But I'm also going to split this model into groups of 2 as well. So I have 1, 2. Now when I do 5 times 2, I get 10. And when I do 4 times 2, I get 8. Now when you see this fraction, you see we have 10/8. So again, my numerator is larger than my denominator. So what I have right here is I have 10 parts shaded in, which I do have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Don't forget about those extras. And then it is out of 8 total parts. So remember, this is out of 1 whole. And 1 whole, in this case, for this equivalent fraction, has 8 parts. So I have 1, 2, 3, 4, 5, 6, 7, 8. So I have 10 parts shaded in out of 8 parts, which makes up a whole. And that is why I have this extra model over here. And that's why 5/4 goes past 1 on my number line. So today, 5th grade, when you move on to your problem set and homework set, please make sure you use these notes to help you out. A good idea for when you are creating your visual models is to make sure you fill in your number line, and then make sure you have a model filled out just normally, and then you can split it up. I would normally start with groups of 2, then move on to groups of 3, then move on to groups of 4, because those are going to be your easiest numbers to work with, and they're going to be the easiest models for you to make, so you're not splitting them up into these super big groups. If you need any help, please, of course, let me know, and you can move on to your problem set now.